Hi, everybody. We're here with Module 3 today, where you are going to explore some things about computer science and STEM. So, this one can be a little anxiety provoking for some of us, but do not fear. I am not concerned about how sophisticated your coding skills are. Not at all. In fact, this is an opportunity maybe for you to grow a little bit in learning about computer science, but certainly not we're not asking you to become a wizard with technology in that way. Coding and the idea of building code can be kind of scary, but it's also a really good opportunity to kind of dig into how computers really work. Because you might be asked to do some of this stuff with your future students. Computer science, you've probably heard people talking about it. It's kind of a hot word right now, hot topic. The state of Indiana just added requirements that every student will graduate by, I believe, 2021 with at least one credit in computer science. So it's a big deal. And one of the reasons why is that there is a huge shortfall of jobs in this area, or for people to take these jobs. A lot of people, when they go out into the workforce, when they graduate from high school and they go to college, they don't choose to go into computer science. Or cybersecurity or computer networking or a lot of the other areas that are related to that. Those programs are small. Heck, at PNW here we're talking about having to combine those programs or wrap them into other things because they're too small and possibly unsustainable. So that's shocking when you think about how much opportunity is out there. They're predicting that there's a shortfall of qualified people to take positions in cybersecurity of over 2 million by like next year. It's a huge number. So that is why this push is on, and it's a real need. So teachers are being asked to help kids become interested in the subject. Maybe they choose not to go in the field after all, but at least they're exposed to it. They get an idea of how code works. They develop some of the logic and problem-solving skills that go along with it, and they might actually become interested in building their own apps, creating programs, doing web development, all the different areas that coding covers. So that's our goal, is to explore this topic in a little more depth. You may already know a lot about it, and that's great. Tell us what you know. That part that's the other side of things. You may already be very familiar with it, and that's super too. Tell us what you know. Share with us ideas and resources that you have. In our Flipgrid discussion, we will talk a little more about STEM in general. Computational thinking is sort of a term that we ascribe to all levels of understanding computers and STEM within the context of all disciplines. So, how does computational thinking fit into English or the arts? It's not just about science and math. So we're going to try and break out of that box of thinking a little bit and try to expand our horizons to thinking about it on all levels, in all topics, and all subjects. And your Hour of Code project is going to ask you to basically get in there, give it as much effort as you can for at least an hour. Try some coding activities, or one coding activity that really captures your attention, and tell us what you learned. Tell us what you thought. Reflect on it a little bit. So you'll write a short paper, 1 to 2 pages or so. Share with us what you did, how you feel. Do you feel like you accomplished something? Did you think it was easy? Did you think it was hard? All that. So, for example, and there's several links in there, but for example, I have a couple of our suggested resources up, like Scratch. Scratch is a really nifty tool. It is a building program. It's a block building programming style, so it's very popular. You'll see it built into a lot of things. So for example, I'm just going to kind of randomly click on something in Scratch. Now, I created an account, but you don't really have to unless you want to start creating your own code in it. But you don't have to start from complete scratch. Sorry for the sorry for the pun. But and there is a Scratch Junior too, for those of us that are interested in working with littles. There is a Scratch Junior, and it works on tablets. This Scratch version works on anything, including your computer, but you can run it, you can see what it does, but you can also look inside if you want to by remixing it or just seeing inside and seeing what it's all about. If you remix it, then you can make it yours and see how it's all put together. So you can see that each one of these little items is a block that tells the computer a step what to do. You know, when the flag is clicked, it goes to that coordinate. It switches out the costume, the look of an item on the screen, and then it starts to commence to do things after that. So each item typically has its own program attached to it. This is a more complicated one, perhaps, but there are tutorials built into this to help you work through it if you want to try your own Scratch project. There's also code.org, which is another really great tool. They have tons of stuff. You can spend a lifetime just learning what's here on code.org. They have self-guided tutorials. They have full-blown little classes online. They have classes in person as well. So you can actually sign up to participate in classes that are offered locally with a real live teacher facilitator. These are really great opportunities that a lot of teachers participated in every year, especially in the summer. But my suggestion for those just starting out would be to perhaps go under Learn when you first enter code.org. And that's where you'll see all the different items, all the different course catalog opportunities. But they have this Hour of Code section. It's devoted specifically to running Hour of Code um, things with your students, activities. And there's a ton of tutorials. So whatever you're kind of interested in, they've got something for you. So, I mean, there's Star Wars, there's Disney, there's sports, there's little silly things, there's just everything you can think of. And there's some that are a little bit more like technical. There's some that are meant for younger children. They will give you suggested age ranges. They have teacher guides. They have some really fabulous stuff here. So, like if you click on the Frozen one, it will kind of lead you through some stuff. There's a video, usually some sort of introduction, and then the video will introduce the students to everything and give them their instructions for what they're going to be doing, and they follow along. And usually built in an environment like either code.org Studio or Scratch or something else, and so they start building whatever to solve the problem or create an app or create a really cool thing, whatever it is. Whatever Basically whatever floats your boat. There's no right or wrong here. Have some fun with it, especially if this is your first time doing anything like this. Explore, be open. You know, build up that growth mindset stuff and think about what you could take advantage of with future students, little ones, big ones, whoever's in your age range, where you're interested in. You'll be able to find something for them. You'd be amazed at what's available for your K2 audience. Some really cool stuff. But for older kids, of course, the sky's the limit as well because they're readers. So there are non-reader things and reader things and everything in between. So be open to it, have some fun, and the paper that we're writing today this week is pretty short. So don't worry too much about what you're saying. So much as get engaged in it, and give us your full opinion of what you thought, how you could take advantage of it. So that is this week's module, and be sure to ask if you have any questions.